25257. So basically, our problem was to interfere before the withdrawal at the very last step, that we have to stop the withdrawal before happening. So we have proposed a system called Cyber-SURAKSHA. The Cyber-SURAKSHA system is a fully AI-driven predictive intelligence framework to provide law enforcement with real-time analytics, and has it forecast the cash withdrawal hotspots. The core architecture is hybrid system combining machine learning and graph analytics. Then we have used the core AI module would have the core AI module engine would be comprised of two modules. First one is the predictive engine, and the second is the network analysis engine. The first one uses the XGBoost for pattern recognition, and the second one uses graph neural networks for model for financial transactions and to identify, track, and predict the activity of interconnected money mule networks. Apart from that, we have also given a functionality of like a heat map, and I'll show it to you further in the tutorial that we have implemented some of it. And at the last, we have implemented an automated multi-channeling alert system that pushes the and validates the high-risk coordinators via SMS, email, and secure APIs to proximate alias. Then what's different and the most showstopper of our idea is that it would have a multilingual support for the wide variety of India. Then it would be secure and encrypted, like all the data would be on a government cloud. Further, it would have a very simple interface. We will build a cost-effective solution, and it would also work on low bandwidth, hence supporting in both urban and rural areas. Also, for the immediate action, it would have clear audio and visual alerts. So here you can see a use case diagram of our idea, like how the whole loop would work. Coming into some technical details, as I explained the algorithms, apart from that, the technologies we are going to use is widely available and has a lot of support. So if we are thinking of implementing this solution on a large scale and for very long year, so we can definitely do that. We have used Python fast API for backend. Then the front end is in React.js and Mapbox. For AI ML, we have used the standard core libraries like TensorFlow, PyTorch, and Scikit-learn. For the database, we have used the state of the art PostgreSQL, and for the deployment, we have on the government cloud, we will use Docker and Kubernetes. Coming to let me show you a small simulation of what our idea is. So basically, we have made this simulation. So when I click on Start Simulation, so suppose in this scenario, data collection would be take place, then AI analysis, then network mapping, after that the smart alerting, and then the police station would go. So as you can see here, we will get a live activity feed of what's happening when it is happening. Then there would be a heat map of the area. Suppose here we are focused on the cities, like there is in Jaipur, there is high alert currently, or some transaction is going to take place in few hours at a particular ATM. So in that case, we will give out an alert from our automated alert system. As you can see, we have a lot of alerts going on from SMS to APIs to emails. Like here it is shown that it's a 75 risk, and in Delhi, and it has gone to a local police station and requires immediate attention. Then we would send out an email to regional bank branch, like it's a suspicion transaction cluster in Bangalore, risk score of 61%, basically mapping everything out and sending out alerts and stopping the transaction from happening. Then in the real time, as we are decided to implement this algorithm to be self-sufficient, so as number of cases increase, there would be a sort of, you can think of a graph, like a you can see a system that has RLHF, like the reinforcement learning with some kind of human feedback. So the system will keep on improving on itself without like further advancement, but it would keep on in the loop and improving itself. So this would be our whole system. It would analyze the cases, like how many cases come on the I4C website in the cybersecurity, and then it would generate alerts. And this would be the kind of system that would like work in real place. We will definitely improve the dashboard. Then as I showed you, like the simulation, some of the key advantages of our particular system is that it has data availability. Our system is designed to securely connect to existing APIs from the national cybercrime portal and our partner banks. The data streams are already in place, so that's a good thing. Then I told you about the self-improving AI. Apart from that, our solution, the network intelligence is like that. We will. It is very faster. Like while we push for faster data, our GNN gives us a huge advances. It can flag suspicious mule accounts before they are even used in new crime, making our intelligence valuable even in for the small delays or things like that. Then we basically, our idea is we don't just predict hotspot, we map the entire criminal network of mule accounts. This gives us police a strategic advantage that isn't lost by a few minutes of delay. So this was then we came to our like potential impact. So it would have a very, as you can see, it would have a very good impact because it would shift our perspective from reacting something to basically like preventing something from happening. Basically our system would be proactive, as I can say, since we are stopping it the money from like getting out of ATM before only. So it also boosts efficiency and officers morale. Apart from that, for citizens and financial institutions, the beneficiaries would be there. Like it would provide a proactive shield against fraud, then it would drastically increase fund recovery rates, and it would build trust in the digital ecosystem. Apart from that, the economic benefits would be like directly savings for citizens, and then reduce investigation costs. Obviously, because since we are implementing an automated system there, the societal benefits would also be huge since it protects the most vulnerable ones first. For operational benefits, it would be optimized resource allocation, and it would improve collaboration and data driven policing strategy. And for our research and references, since we are MTech students, so we have researched it thoroughly. We have referred a lot of research papers for implementing these algorithms. Apart from that, the algorithms we are going to use are like very open sourced and very widely used. So it would not be a problem like implementing or changing something in the future as and when the government needs it, and it would be very secure. So it would have LSTMs and the graph neural network, and we are also thinking of implementing some kind of chatbot in it. So we can use some sort of LLMs too in the future. Suppose if someone wants to chat with our system and figure out what particular metrics means or something, so he can also definitely do that with our system. So I think you have gotten a gist of our idea. So that is our idea, Cyber Suraksha.